In this video, we'll look at electrostatics. Electrostatics can be defined as the science of static electricity. So electrostatics can be defined as the science of what? Static electricity. Or we can define it as the study of charge at rest, or the study of slow-moving charges. So we know that we have two types of charges: positive charges and negative charges. These positive charges is usually denoted by the symbol what? This is a plus sign. And a positive charge is a fundamental property of matter which indicates that an object has more protons than electrons. So when an object has more protons than electrons, you see that it could have positive charges. It means that the protons are in excess. So, and the positive charges has their lines. Of course, this is a positive charge. You see that the lines of force radiates away from the charge. Okay, so a positive charge is characterized by electric field lines that emanate radially outwards from the charge. So these lines of force represent the direction and the strength of the electric field around the positive charge. And of course, one of the properties of electric lines of force is that they don't cross each other. So how can we obtain a positive charge? Positive charges can be obtained, of course, when you rub, for instance, glass with silk. So when you rub glass with silk, one can obtain a positive charge. You notice that the glass rod acquires a positive charge. So this is the glass rod and this is the silk cloth. So when you rub this glass with these silk cloths, you notice that the silk becomes negatively charged. This is because electrons are transferred from the glass rod to the silk cloth. The glass rod in turn becomes positively charged due to the loss of what? Electrons. So when one rubs glass with silk, the glass rod acquires what? A positive charge. And how do we test this? To test this, when you now bring two rods, okay, two glass rods, and you bring it side by side, what do you notice? You notice a repulsion because they are of like charges. And one of the fundamental laws of charge is that like charges repel while unlike attracts. You see that these are positive charges, they are like charges. So you see repulsion here. So when you bring two glass rods that have been rubbed with silk side by side, you notice what? Repulsion. So now let's look at negative charges. Negative charge is usually represented by this minus symbol and is a type of charge that is characterized by electrons. So it is carried by what? Electrons. And it's also a sign of deficiency of protons. So you notice that the electric lines of force now point towards the charge. So the electric lines of force originate from infinity and terminate on the charge. This means that the electric lines are directed inwards. So you now see that electric lines of force for positive charges are directed outwards, note, and for negative charges they are directed what? Inwards, the electric lines of force. And what are electric lines of force? They are those imaginary lines that are used to represent electric field. Alright, how can we obtain a negative charge? Ordinarily, one can obtain that by rubbing ebonite rod with 4. This is the ebonite rod. This is 4. This is just like animal skin. So the ebonite acquires a negative charge. So how do you test this? So to test this, you bring two So to test this, you bring two ebonite rods, you place them side by side, not touching, and you notice what? Repulsion. So this was made evident as far back as 640 BC when an American physicist, Benjamin Franklin, conducted this experiment. And he noticed that when a glass rod rubbed with silk is brought close but not touching, so an ebonite rod that has been rubbed with fur, that attraction exists. So when you rub glass rod with silk and you bring the glass close but not touching to an ebonite rod that has been rubbed with fur, you notice what? Attraction, because the ebonite rod rubbed with fur has acquired negative charge while the glass rod is positive. So you notice that like charges repel, but in this case now unlike charges what? Attract. So basically any substance rubbed with another under stable conditions will become charged to some extent. So a metal rod held in hand and rubbed with fur or silk does not develop charge. What is the reason? Because the human body is a conductor. So when, for instance, you are marching on the floor barefooted and you hold a metal rod that has been rubbed with fur or silk, you notice that the charges will conduct away from your body. So no charge will be developed. So I've explained this. I say what happens is that excess charge that might accumulate on the metal gets what? Dissipated. To conduct this experiment properly, a metal rod with a plastic or a window handle should be used. So when you now rub let's say glass rod that has a metal handle, that has a plastic or window handle, you notice that when you rub it with silk, the charge that will develop on the rod will remain because it will not be conducted away. So since the handle is an insulator, so it does not provide a pathway for excess charge to what? Escape. So it remains localized on the metal part. Note, the real test of charge is repulsion, not attraction. Why is this so? This is because repulsion only occurs between bodies with the same type of charge. Repulsion, note, occurs between bodies with the same type of charge, meaning that if two bodies repel each other, you can be certain that they are charged. Attraction on the other can occur between a charged body and a neutral body, so making it a less reliable test for charge. So the true test or the real test of charge now is repulsion, and an instrument that has been designed on this repulsion principle is the gold lever electroscope. The major carrier of electricity is the electron, and it has this mass 9.11 times 10 to the power of minus 31 kilogram. So this is the mass of an electron, and this is the charge 1.6 times 10 to the power of minus 19 coulomb. For conductors, however, such as electrolytes, both positive and negative charges take part in the conduction of electricity. So we look at insulators, conductors, and semiconductors. Insulators, we know they have the atom tightly bound. So unlike conductors in which electric charges are free to move about. And of course we know that it's this movement of charges that leads to generation of current. So when we have metals, okay, that are conductors and insulators, metals that are in between these conductors and insulators, we call them semiconductors. Okay, they are partly conducting and partly insulating. So a good example of this is silicon. Another one is germanium. We have tin oxide, gallium arsenide, etc. So the electrical conductivity of a semiconductor can be changed by doping. So of course we say that this semiconductor is partly conducting. So if one wants to change the electrical conductivity of this semiconductor, you can dope it with other metals. That is by adding impurity. So this is the addition of impurity to a semiconducting crystal, and that is what is called doping. So in our next video, we'll look at charging of a conductor. If you have enjoyed this video, give it a like, share it with your friends, and subscribe for more updates. Thank you.